Hey, hi everyone. I'm Prashant Jagannathan. I'm an offering manager for IBM Spectrum Protect Plus. It's a modern data protection portfolio. In this presentation, along with me, there'll be Jim Smith as well. Jim Smith is a chief architect for the Spectrum Protect Plus portfolio. In this section, we'll be going through some more in-depth into the technical overview of the product itself. So to start off, let me just do a quick recap of the product portfolio. Spectrum Protect Plus was introduced as a enterprise level data protection, data reuse software. It's a relatively new product offering. The first public viewing of it was at VMworld in 2017. It was GA the end of the year in November 10th. The latest update that we have added is in 10.1.3, which was literally last week. We went GA last week. The product supports hypervisors, VMware, and Hyper-V. In terms of applications, we support Microsoft SQL Server, Oracle, IBM DB2, MongoDB, and Microsoft Exchange Server. The primary use case is data reuse. Data protection has been the traditional use case. We are going beyond that, providing more than just data protection, recovery, and providing support for operations like test dev, improve DevOps, and use that data for reporting on analytics.
Prashant, have we had 10 versions of this since that 2017 day?
Feels like it from a product management perspective. No, so we've started off with the product name numbering as 10.1.0. We just had to match
VMware numbering.
Our other data protection and other offerings in the portfolio itself. So we started with the 10.1.0. So technically, this is a fourth release, 10.1.3. Good question, though.
I was thinking the same thing.
We leapfrogged to 10 from 0.
Wow.
So the key design principles, we focused on 4 of them. The first one being easy setup. We provide it as a simple OVA file for VMware, and there's a Hyper-V version of the same thing. It's a fully packaged appliance. It comes with a management server, the backup repository, and additional proxy components. You can separate them into each individual nodes as well, but as a start, we provide that all-in-one appliance.
And appliance upgrade path? It has an integrated tool to handle upgrading itself?
That is correct. So there are software updates we provided as ISO files that includes all the components. If there's an app agent that we need to do that has the same patch has the app stuff, the server components, the storage components. So it's all provided as a single patch package.
Out of curiosity, what operating system does that appliance run?
It's a Linux platform. It's
Linux.
It's CentOS.
Good.
That makes it easier for us to package it and
license outside of Windows.
That's right. We also have a deployment option there's an on-premises. You can do the OVA or Hyper-V. We also support in IBM Cloud. It's the same offering, but it's automated deployment. A customer can go purchase the data protection and say they want to buy IBM Spectrum Protect Plus. It'll go ahead and deploy the software for them automatically.
On the appliance, what's the update process look like? Is it deploying a new OVA, or is it like attaching an ISO to an existing OVA, or does it just reach out to the internet?
Right. So I need to clarify the term appliance. It's a virtual appliance. It's a virtual machine. So the first time is the OVA, and from that point it's patching. So you deploy the first version. If you started off at 10.1.0, you keep updating in-place upgrade to get you to 10.1.3.
Okay.
If you're starting scratch today, you'll have a 10.1.3 OVA, and from that point you'll just do an in-place upgrade.
Okay.
Any plans for things like hyperconverged secondary backup, that kind of thing? I know guys like Cohesity, Rubrik, even StorageCraft that's doing those stuff.
Right.
Even Commvault, right?
Right, that's something we're still exploring. We are also looking at if you want to do a software-defined hyperconverged infrastructure.
Like a reference architecture.
Like a reference architecture or build everything ourselves. So today, that brings us to my good segue. There's an IBM blueprint that provides a reference architecture of how you deploy it today, what type of storage you could use in the back end, what are the performances that you see. Jim will explain that a little more. So there's a reference architecture today. We are planning to expand that beyond to make it fully hyper-converged to see if we can add more compute as well as some networking capabilities for spinning up and spinning down resources.
All right, sure.
So what kind of storage would you actually attach to it? For high capacity, fast,
Flash.
flash, VME? I don't know.
Right. So today the blueprints recommends block storage. That's a minimum what we are suggesting in terms of performance. Flash, SSD we provide as improvements that those are not mandated. It's just spinning disk, but as a block device. And the reference architecture are built on IBM storage, the Spectrum virtualized portfolio.
Okay.
In terms of the data protection itself, it protects databases, apps, which are on premises, are in the cloud. I just wanted to pause for reaction.
Yeah, it's spelled wrong on the slide.
Yeah, I just wanted to make sure I engage the crowd. Yeah, I know. So it's either hosted on premises or in the cloud. It's incremental forever. That's the theme that we follow. Again, like we mentioned before, it's across the board for hypervisors or applications. It's always incremental forever, block level changes, and it's all these incrementals are still stored as a full copy.
Is that a choice, or is that something you can override?
It's how the product works.
Right. So imagine the scenario you've got a database that you're backing up with RMAN, or you're doing some sort of backup, and then you're now doing incrementals that you're taking out of the product.
Right.
And you do a major update on that database, and now it's a completely different version.
Right.
Are you really saying that you can then just carry on doing incrementals and take the risk that if you had to restore back to a previous version of that,
Right.
where you brought back the data from, say, 6 months ago, connected it to the database, that it would still work? Or would you want to force a new full backup at that point in order to make sure that the copy you took was fully compliant with the new version of the database and data structures? Because it seems to me that might be a risk that you would want to try and avoid.
Right. So that's a good question. So if there's a new version and they basically add a new database or something new to the data itself, that incremental backup will.
I don't mean the data. I mean the apps binaries for the database.
Right. So the incremental backup will send more blocks, right? Because it'll
Well, I'm
send
not
all the
changing-
new blocks. Those are new information that.
I'm not changing the data. I'm changing the application. So now,
Right.
a very small amount of the data might have changed, perhaps, but there might be a risk that the data structures, the way that database worked, are slightly different between versions of the database. So I restore a different version of the database back,
Right.
and the application then looks at it and goes, "Oh, that's an old version. I can't talk to that."
Right. Okay.
But
there-
I want to force a full backup.
So there is an option to force a full,
Okay.
but it's a user-driven option. User can say, okay, at this point, enforce a full.
Fine. So that's okay. That's
Right.
fine. Because if you're doing an upgrade, then the DBA knows that he has to kick off.
Correct.
A full
Right.
in that
Yeah.
sense.
So typically, when we've seen customers from our experience doing this incremental forever, if they added new set of data or changed any of these options, the block level changes there'll still be some blocks associated with those changes, and we're sending the blocks over. But to that point, if a customer is not completely on board with that, there's an option to say force a full backup as an option. The next time the backup runs per schedule, it'll force a full.
Okay.
Okay. In terms of management, again, there's a centralized management. We are doing a policy-driven management as well. So there are policies that come packaged with the product. There's a gold, silver, and bronze, which has schedule and frequency you can assign your workloads to. You can add more as well. There's granular role-based access control. So we integrate with LDAP as well. So if you want to use native users for the product and assign them roles and privileges, you could do that. Or you could say, use my authentication through LDAP. We can use that to log into the product as well. From terms of recovery and reuse, instant data access, again, that's basically the heart of how the data is transferred and how we store data. So any data that it's landing on our backup repository, you can instantly mount it and use it for testing, your sandbox testing, data recovery, et cetera. And the data is all indexed and cataloged in the management server. So you can search for it. You can search for an app. You can search for a file within a VM to do your granular restores. Okay. At this point, let me just do the build out and hand it over to Jim.
All right, hello again. My name is Jim Smith. I'm one of the architects for Spectrum Protect portfolio. I've been with, as I said, with ADSM and TSM. Will be 30 years here, coming up shortly. Prashant actually did a very good job with the technical overview, so I'm going to be going through this rather quickly, and we'll just take any other follow-up questions. Prashant talked a lot about some of the data paths. We're going to kind of point out a few of the main components. First is the Spectrum Protect Plus server, the VSnap repository, which is our quote-unquote storage pool for this, and a little bit, we use the term agentless backup, and we talked about the fact that we're deploying agents. And that's true for every workload except for VMware, because you can't actually deploy agents on ESXi. So we have like every backup vendor, we have a proxy that you need to use that's responsible for reading and writing data to the VMware data stores, the vSphere data stores. So we'll talk about those three components. Then we'll talk about basic data paths, ingest, and recovery, reuse that Prashant had mentioned. We'll talk a little bit about replication and about cloud offload as well. So the VSnap storage server, Prashant did a very good job with explaining how we land data. And I think it was pointed out, someone said here that we're emulating snapshots. And that's exactly the best way to think about this model. Imagine on the left side in the production system taking software snapshots on a daily basis. And that was your method of backup. We're basically emulating that. And we're just moving all the data off to the VSnap server and landing all the data. So all the blocks and all the metadata is actually emulating what you would be doing if you're just taking software snapshots on the production server. So as Prashant said, data lands in the production server. We take a snapshot with any workload because the data has to be in a consistent state. It's no good if you can't restore it. And then we take the blocks. The first backup is usually pretty uninteresting because you're just looking at the used blocks, and we move them over and we write them in the file system, basically emulate on the file system on our VSnap storage device, emulating how the layout would be on the source app. So that's a VMDK file, it's an MDF file, whatever the native format is for that application. And then once all the data is written, then we take a snapshot on the target system, and that becomes our recovery point. And that recovery point is registered. That's the information that's registered up into the Spectrum Protect Plus server, the information about where that data is. So basically, you take a backup of a virtual machine. It has two VMDKs. We're basically telling the metadata server, hey, you've got a backup on this day, this time. It consists of these two VMDKs, and there's some virtual machine information. And here's where you go find it. There's a volume here on this VSnap repository. On that volume, you go to XYZ file system, or XYZ if you're on the other side of the ocean. And this is the snapshot ID. And now you have file system access. And that's where we get the instant access, or that's in with Microsoft Applications Exchange SQL Hyper-V. That's a LUN sitting there in the VSnap server. And we're able to mount the LUN back to whatever repository we need and make the data available.
So is the VSnap server different than the Spectrum Protect Plus server?
Yes, so the Spectrum Protect Plus server is the metadata catalog. It's a bunch of catalogs that are cataloging recovery points, your policy information, this file index that we're going to talk about a little bit differently. It's not in the data path. In fact, there's only one of them. There's only one of them ever in a deployment. So even if you have a multi-site, we'll look at a multi-site deployment. You have 2 sites or you have several branch offices, you're going to have one Spectrum Protect Plus server. And then you're going to build these VSnap repositories up. And that's basically, we talked about what they're doing. So you're going to build VSnap repositories up in each site, so because you want to localize your data movement into the VSnap repositories. And as Prashant said, we have a blueprint that basically tells you how to build them and how many to build.
On the Spectrum Protect Plus server, is that what's pushing software for like agent-based backups?
For the agent-based backups, yes, that's what's emulating, that's what's pushing
But if there's only one of those and I have multiple sites, then doesn't that seem really inefficient?
So the question is if it's inefficient to push out agents, but these are very small agents. Well, we're not talking about a lot of code.
Understandable. I just feel like if you're going to push an agent, why not have it in the data center I'm trying to push it to?
Yes. So yes, you're absolutely right. There are efficiencies. We're looking in future roadmaps of having catalogs replicated for high availability, and there's other efficiencies you get from having the catalog available. But for now, for the model we have now, we have one catalog basically, and yes,
One catalog?
one Spectrum Protect server, one set of
For all
catalogs.
the data that's being protected in that environment?
Yes.
It's a catalog, not an index.
It's a catalog, not an index. So we'll talk about, when the data lands in the VSnap repository, the VSnap repository is doing a lot of heavy lifting. It's keeping track of the blocks. It's compressing the data. It's deduplicating the data. It's keeping track of the dedupe chunks. It's taking the snapshots. All it needs to report for your big your big file server that's sitting in a VMware system as a VM, all it needs to report is basically, I've taken a snapshot of this virtual machine. It's got a couple disks. Here's where you find them. You're not having to track all the individual files within a particular virtual machine. You're not having to track a bunch of information with
But you're
SQL.
tracking the snapshot levels, clones, and that sort of thing that are taken from those
Yeah,
images.
sure. But that's
That's tracked in the catalog, right?
that's all tracked in the catalog. But that's a smaller amount of information. It's not like, TSM was tracking a lot more data. We're tracking deduplication chunks. We're tracking all files, like on a file server. We're tracking all the files at a file level. This, we're just simply cataloging the fact that we have a snapshot and some information about where to go find.
Catalog a single point of failure for the system, or?
The catalog is a single could be a single point of failure. We have protection mechanisms, which we'll talk about. You can back it up and recover it.
Okay.
And that's part of a healthy deployment.
You install another Spectrum Protect Plus server to back up the Spectrum Protect server that you've already got. Because then you just go around in Inception and back each other. They could back each other up, couldn't they?
Yes,
So that
they
when one failed, you'd always have a backup on the other one.
So we do, you're going to see we treat the catalog backup as another application. We can ingest it into a VSnap server. We can replicate it off to another VSnap server. We can put it out in the cloud. As Prashant mentioned, spinning up a Spectrum Protect Plus server, it's an OVA file. It's something you can do in a few minutes' time. So we'll talk about the fact that you can spin up another Spectrum Protect server rather rapidly, reconnect it to a VSnap server that has a catalog backup and recover the catalog. Again, the catalogs we're talking in minutes, highest 10, 20 minutes as far as backup recovery time. This is very different than backing up a big DB2 database, which is sitting behind Spectrum Protect TSM.
And the VSnap server, what kind of server is that? Is it an appliance?
So the VSnap server is basically the heart of the VSnap server. It's a file system sitting on block storage. We need block storage. The first thing we do with it is we drop a file system. It is shipped as an appliance. Or you can build your own. We ship
Is it Linux, Windows?
Linux. It's a Linux system. And again, the blueprint will basically tell you how big you need to build these VSnap servers. So in the blueprint, you basically will tell it your workload. You've got so much front-end Oracle data. You have so much front-end VMware data. You tell it how much data you plan on retaining, 30 versions. If you're replicating the data, change rate, estimation of, what do you think your change rate is? What do you think your growth rate is over time? What do you think is reasonable for compression and deduplication rates on your data? And then how long do you plan on keeping the system running? Typically, we see plans 3 years out, 5 years out. This all gets put into a spreadsheet, and it will spit out and say, you need this much capacity, and we recommend for this much capacity, you might have 2 VSnap servers or 3 VSnap servers. You put this much spinning disk behind them. You put a little bit of flash there for log and cache. Here's how much CPU, here's how much memory, and that's basically what the blueprint does for you.
And the VSnap storage is deduplicated and compressed, and a VSnap server can be replicated
Yes.
across distance, like synchronous replication, or
It's asynchronous replication.
asynchronous
Yes,
replication?
and so we are retaining the data. When it lands in the VSnap server, it gets compressed, and these are all optional.
Turn onable?
Compression is on by default, and we found no reason to turn it off. After it gets compressed, it gets deduplicated at a block level if optional. And again, deduplication, we can sit and talk for the next 10 hours about that, but we're incremental forever.
Yes.
So because we're not doing fulls all the time, you've already got data reduction built into the system. And then it can be encrypted optionally as well. And that's something when we send it over the wire or out to the object storage, we keep it in compressed format. And as Prashant mentioned, when we replicate or send it off to Cloud Object Storage, we are only sending the incremental bits.
I'm not sure that you're going to touch on it, but could you just explain the data flow of how the backup data is going from the source environment and where it ends up? Is it going directly from, say, a vCenter or a VMware environment directly to the VSnap server?
So in the case, let's use the case of a virtual machine. The first thing we do is we call vSphere to take a snapshot of the VM. So now we have a consistent set of data, VMDK.
What's calling that, by the way? Like what component is calling that snapshot?
Which component is calling for this? That's the server,
The Spectrum Protect?
the Plus server.
Okay.
Plus server, yes, that's right. So the Plus server is orchestrating all of the data movement. It calls, takes a snapshot, then we look at the change block tracking information, and we say for the first backup, we say give us all the unused blocks, and forever after we say give us the used blocks. The VADP proxy, in the VMware case, we have a proxy that then will connect to the data store, read the data from the vSphere data store, and then send it into the VSnap server. It mounts.
So, okay.
Proxy is instantiated where?
What's that?
And the proxy is instantiated where?
The proxy, usually we recommend sitting on the VSnap server itself.
I was just about to say, yeah.
So that the writes are localized into the file system.
Right.
It can be off, and you can have a VADP proxy somewhere else, and it NFS mounts to the VSnap server, just an NFS mount, but you've introduced a hop now.
And in terms of sizing, obviously, these VSnap servers are not going to be parallel. I mean, how many connections can I reasonably get per VSnap server?
How many connections for?
How many concurrent backup sessions? Say, 'cause I've got some
You're
cases
thinking the
very
same
similar
thing as
stuff
me.
like that, and one of the problems we've run into a few times is occasionally, like I'll have virtual machines with like 10 or 12 VMDK files, for example, and when I try to hot add all of them to a proxy type mechanism, well, the thing goes, well, I can only have this many slots open,
Yeah.
or I've only got this much bandwidth available.
So that's a very good question, and there's a lot of different answers because you're up against you're either up against NFS mount limits or iSCSI limits or hot add limits.
Yep.
So what we try to do is we try to manage we have settings that say only allow from any ESX host by default X number of sessions at any one time.
Okay.
And try to manage it that way so that you're not creating a backup storm and trying to go after all these different resources at the same time.
So in the same thing, your tool that does the VSnap server sizing, will it take that into account as the number of VSnap servers I need when I say I have, 200 virtual machines on this site? It will recommend based on that?
The current blueprint is based solely on size,
Okay, so it's strictly
front end size. Yeah,
as opposed
that's something we've thought about, but it's not there yet.
Okay, no.
So the reason I was asking the question, very similar to Eric actually, was just to try and understand how you would scale this out, because if you have lots of stuff to protect and lots of data, is the data path directly from the source to the VSnap server? It's not having to go via
Right.
the Spectrum Protect server.
No,
It sounds to me
Spectrum
like only the
Protect is
orchestration is going via that route,
So-
but no actual data flow is going by
Correct.
that route.
Plus server is purely orchestration. It's
you-
metadata and
Yeah,
orchestration.
so you can scale that bottom layer out for throughput purposes,
Yes.
That's right.
but you don't have to worry about that for the,
Correct.
okay.
Yes, so yes, it's definitely a scale-out model with the VSnap servers, because you want to get some concurrency in your writes,
Yeah.
in your I/O.
Just continuing on that scale-out concept, each VSnap server is in its autonomous deduplication domain.
Each VSnap server is an autonomous deduplication domain.
Right, so it's not a scale-out
A
repository.
global deduplication.
It's not a
across
global,
all these snaps.
no, it's not.
Each VSnap server is an autonomous thing and would be ultimately the target for a given virtual machine. So he's not getting backed up to one VSnap server one day and then another VSnap server the next day.
No,
So my jobs would specify destinations. Okay,
Very similar to the classic architecture.
yeah.
It's a media server at the end.
Right. Yeah, we
Or
have a
whatever it's called. In.
correct. We have a concept of a site, a logical site grouping
Yes.
of a bunch of VSnap servers, and you're probably going to that.
Okay.
that's fine. You were doing good.
Right. So during the backup in a policy, you will say, okay, which for the policy, what site do you want to be the target? And
Right.
when you're assigning the workloads to the policy, you can assign it to the policy, and within that site, it'll identify which VSnap has the most available capacity, and then it'll route it to that.
Okay, so I don't choose the thing, I just choose the site and it
You
goes.
just
"You've
choose the
got
site
this
and
many,
it'll choose the
I'll pick
VSnap
a good
for you."
spot." Okay,
Correct.
that's one less decision to make.
Did we get that, your question answered?
Yeah, that's exactly what I was trying to work out. There was just, from that scalability perspective, where the data is flowing to understand where my constraints would be if I was designing an architecture. That's what I was.
I don't know if I got it wrong, but the Snap server needs an array to work, or can I use a JBOD?
So
Because it becomes quite expensive if.
Yes, so the blueprint is, we have a blueprint that is on the Storewise and it's on a Supermicro JBOD. So we have found that for just storing these snapshots, just fast standard disk is good enough.
Okay.
We do have where we recommend the cache, the solid state NVMe is with a small cache and small log, small relative to the size of the VSnap repository for logging incoming writes, although that's not as necessary anymore because we've decided to turn off disable synchronous
Okay,
writing.
so the VSnap server could be any server with local hard drives
Yeah.
protected somehow.
As long as it's block storage, VSnap could be on any server.
And then we're recommending that DRAID 6 or RAID 6. So either it's sitting on storage that has DRAID, or through the file system, we'll let the file system provide the RAID for you.
Okay.
So Prashant also mentioned, just one key point, mentioned that all this stuff comes bundled together, the VSnap repository, the catalog server, and the VADB proxy, and that's great for just playing with it and testing it out. But in the blueprints, the first thing we tell them is, okay, you're going to want to separate your Spectrum Protect Plus server and only put that on one machine, and that's all that machine does. Turn off the VSnap repository, turn off the VADP proxy on that box, and build out the VSnap repositories and the VADP proxies at other locations, on other hardware.
So who do you see as your target customer?
I will let Prashant go.
Right. So first, we are targeting towards any customer that's using virtualization, so VMware, Hyper-V customers. And in terms of the market size, it's mid-market to upper enterprise. Since we have already a big customer base with the TSM customers or the Spectrum Protect customers, so we are leveraging the Spectrum Protect customer base as well as going to mid-market and enterprise for new space as well.
Did you mention storage snapshots and I missed it, or?
I did not mention.
We did not mention.
All right, so we have other products in the portfolio. Sorry.
No.
Yeah, we have other products in the portfolio like a Spectrum Copy Data Management or Spectrum Snapshots that leverage the storage snapshot functionality. So that's not something we're talking about today. In this, it's purely backup data movement from primary to secondary.
So from your point of view, how competitive is this product in that mid-market segment?
Right. So we, like I said, we just introduced the product last year. We have about 100 plus brand new customers. And beyond that, we have our existing Spectrum Protect customer base as well.
So you're selling into those Spectrum Protect?
Yeah, we are. Again, any virtualization customer is a potential prospect. So we have been success with both white space and the new customer base, as well as the existing customers who are looking for virtualization protection in their environment.
Right.
But just to follow up on that question, if you're selling into existing customers, I might have missed it, you may have said it already, how do you help those customers transition their long-term backups that are in existing VSM/Spectrum Protect into your new product?
Right. So typically when we're going into the existing Spectrum Protect customers, they're looking for a virtualization solution. And they also want to use their existing infrastructure. So when we come in, we're coming to back up that virtual machines. And as a target, we are supporting as offload into the Spectrum Protect server. So they can use the data repository to offload and keep their existing.
So I'm thinking that you would want to target customers to move to this as the new platform
Eventually.
wholesale. So, and they'd want to get rid of the old equipment. They'd want to decommission their old backup environment. So if they still need to retain backups long term, how do you help them decommission the actual hardware and environment and move those backups into the new environment, or do you not do that?
So far, we're talking about the VMware workloads because Spectrum Protect is still protecting a lot of file system workloads, and Spectrum Protect Plus is not there yet with the physical file system workloads. Most of the customers that we talk to, first of all, if they're on the data protection for VMware product, they're probably still on it for a number of years through their service contract. So this is not an immediate shift. We're not telling the customers, you've got to get off of that. We're telling them you're still supported. We have typical TSM 8 Spectrum Protect lifecycle. They're there. We've found surprisingly that most of the VMware workloads, when we talk about moving them off, they're not being retained for longer than a year. We've been asking this question, when we talk about migration, what are you thinking about? What are your retention policies? And does it make sense for us to try to move data around? So far, the answer has been, it's 30 days, 60 days, a couple people have said a year, and we're fine with just aging out stuff. Now that, of course, can change. We can find a customer that's got,
Of course, yeah.
right.
Absolutely.
But so far, that's been the majority of the responses.
Wow.
But
For VMware data, for file system data, I think we're going to find that's a different problem space.
Wow. Sorry, that surprises me. I'm sorry, I don't want to delay too much, but that surprises me because I would expect people running traditional applications in a VMware environment, that might include databases and so on, might have a long-term retention policy.
They do. So they do, and they've been using in-guest tools, and a lot of them, believe it or not, are still using those in-guest tools like the Spectrum Protect Backup Archive client for long-term protection.
Oh, because they've got those hooked up to their tape libraries, which
Yep.
is how they do the long-term stuff.
Okay.
How is this priced? Is it by the amount of data that's protected? How many VSnap servers you have, whether or not you're using?
So there are a couple of licensing models. One is by number of VMs. That's a standalone license model. And there's also a suite component. So suite is by capacity. It's by how much data you're storing in the backend.
So building on that, how do you handle enterprise customers which have, let's say, thousands of VMs or hundreds of terabytes of data? Do you have any special, let's say, enterprise license agreements, consumption?
Right. Yeah, IBM has always had those. The enterprise license agreement.
IBM will always find a way.
But I'm sure you have. I'm sure you do.
and they can bundle with everything else.
Right.
That's a good answer.
Yeah, there are different licensing models. Again, IBM license, I can talk
So-
for a few hours.
Do you also see the product in small, medium business, like some of your competitors in this space, especially in the virtualization? They started
Of
with.
course. Yeah, it's not limited to just the markets that we go.
No, yes, but are you interested in it? Because usually is a problem of pricing and licensing.
Right. So the standalone model that I mentioned, the per VM license, it's priced for small, medium, and large customers, for smaller and medium market. So it's fairly competitive. I'm not going to say cheap, but It's very competitive. It's lower than all the or on par with some of the other competitors as well. So if you're going into the small business like the VMs, it's very competitive in terms of price.
What's the entry-level size for the VMs that you protect?
Entry-level size in terms of the
So
license that we've sold?
Yeah, like 1 to 50?
The minimum license you can buy is 10 VMs.
Okay.
And it's not licensed by the number of terabytes of storage, but by the number of VMs being protected.
Right. So there are two models. There's this by number of VMs or by target capacity. That's we call the Spectrum Protect Suite license. So that's based on the target capacity.
And target capacity is after compression and deduplication effective, or
It's managed capacity. How much is it's from the storage? So after compression, after dedupe. That's right.
It's not raw capacity, but it's effective capacity based on compression and deduplication.
Correct.
Including retention.
Including retention. Yes.
Yeah.
We tend to back-end capacity for that.
Correct.
This is an interesting choice.
It'd be very painful.
Okay, so yeah, that's.
How are we doing with that?
We've been taking up.
Well, good.
Let's do the blueprint.
All right, so we're going to move through. As I said, Prashant has done a good job of covering most of this. We've talked about the blueprints. We've talked a little bit about the fact that you can replicate the data from VSnap servers. In fact, we probably insist that that's something you're going to want to do. The replication, again, the VSnap servers are organized logically into this concept called sites. And so you have a site, you might have a site in New York and a site in San Francisco. And you create these, we'll talk about the backup policies a little later. But you basically create policies that dictate frequency, retention, and placement. Frequency and retention are obvious. Once a day, keep for 7 days. The placement in Spectrum Protect Plus is at the site. So if you have workload to protect in New York, you'll build a site called the New York site. And you'll basically build a policy that says, I want to back up every day, keep it for 7 days, and land data in the New York site, and then replicate that to the San Francisco site. You also build a policy that says, I want to back up into the San Francisco site and replicate over. And then when you go through and you pick your workload, you'll go at the host level and say, this host, I want to associate with the SLA that's backing up into New York and sending data to replicating to San Francisco, and vice versa. If you have the data center in San Francisco, you would use the policy to localize the data movement and then replicate it out. So that's basically how the quote-unquote SLA or the data retention policy.
Cross-replication is compressed and deduplicated data?
As we said, the replication, the data movement is compressed only.
So it's not deduped?
It's not deduped. And if it was encrypted at rest, it's unencrypted and it's protected through SSH across the wire. But then once it lands, it gets rededuplicated if you choose to have deduplication on and gets re-encrypted. And then just to build out of the same concept, you can have multiple sites, remote offices, and again, you're going to have a single Spectrum Protect Plus server that's going to be orchestrating the snapshotting and is going to be in charge of cataloging all the metadata for the operations. And then you'll have your VSnap repositories and your VADP proxies localized in those locations. So the data movement, the initial data placement is all localized. Okay, offload to object storage. As Prashant mentioned, we offload to various S3 endpoints. IBM Cloud Object Storage, either public or private. Amazon S3. Azure Blob Storage, technically not S3. And we've also, we'll see in a second, we've also built an S3 interface, a private S3 interface into the Spectrum Protect server so that we can send data to, if a customer has an existing investment in the container pools, for example, on Spectrum Protect, we can make them look like an S3 target for Plus. And I think we had a solution last year when we talked to you for offloading data into Spectrum Protect, and that had to do with using data protection for VMware, using TSM componentry, and just kind of deploying that and having Plus orchestrate. We're going to forget all about that. Basically, what we're doing now is we're taking the data from the VSnap repository, and as Prashant mentioned, we're pushing it up to the object storage. It's application agnostic, so whatever application can land data in the VSnap repository, we can send it off to S3. You don't need any additional components to do this. It's incremental forever, just like the replication. It's going to be compressed out, and then the object repository will do whatever data transformations. For example, if you land it in a Spectrum Protect server, we found very good deduplication can still take place on the data once it hits the Spectrum Protect server. And you can instantly mount copies from offload backup. And so basically, I don't know if we have a picture of that. But basically what we're going to do is in the VSnap server, we're going to create a virtual volume on that VSnap server. So to the applications, when instant mount is basically providing an iSCSI mount or an NFS mount to this snapshot data in the VSnap repository, right? So when we do this from cloud, we're basically going to do the same thing. We're going to tell SQL, hey, I've got a LUN for you, or we're going to tell VMware, I've got this NFS data store. It looks like anything else from the VSnap repository, but it's not a real volume. It's a virtualized volume. All the I/O is being driven back into the cloud. So as soon as SQL, as Prashant mentioned, SQL or VMware says, I need so-and-so block, ask for a read, and if we don't have it localized in the VSnap repository yet, we'll go out and do the S3 gets to get that block and temporarily put it in our VSnap server repository. So that's how we're pulling off instantly mounting a SQL database or a DB2 database from object storage.
So what determines object storage archiving? Is it time or something like that? Is that some policy that you would set that
Yes.
anything that's over 10 months old will go to that object storage?
So the object storage today is a copy function. It's not a move of data, it's a copy function. So the way we're positioning this is the VSnap replication is good for the protection of the VSnap repository. It provides your disaster recovery. It can provide your operational data recovery. And the object storage is best designed for long-term, if you want to take long-term copies and push them out for more infrequently. And what's that?
Object is the new tape.
Objects is the new tape without the air gap, yeah. That's how we're positioning. Now, we're finding customers that say, hey, we want to skip replication altogether. Can we just use object storage for replication? And we're having those discussions with them.
So let's say you want to copy it every 10 months old snapshots over to an object storage, but you want the retention for those snapshots to be 1 year. So after 2 months later, that snapshot is deleted from the VSnap store and still exists in the object.
Right, so you can have a policy that says ingesting data daily, keeping it for 7 days, and I'm sending it out to the cloud on a weekly basis and keeping it for 7 years.
Yeah, yeah.
And,
but you don't have anything that has a retention policy management over the cloud data, or you do?
we are managing the retention of the data in the cloud.
As well?
Yes,
as well.
VSnap. Okay.
Right.
All right, I got you.
Right. So the maintenance and the cleanup and tracking
that's
is all done by Plus.
Done by the Spectrum Protect
The Plus server. That is correct.
Now, the only time we're not, that's a good segue,
Worm.
thank you, is with IBM Cloud Immutable Object Storage, which used to be called Worm and retention vault, retention bucket, et cetera. And the difference here with the immutable object storage is when you go to define a policy and say, I want to push stuff off on a weekly basis into cloud, and I want to keep it for 6 months, if the target is one of these retention-enabled vaults, and that retention has been set to 365 by 2 days, the cause is going to come back and say, you can't do that. If you're going to put data, if you insist on putting data in this vault, then it's kept for 2 years, period. So that's the that's our engagement with IBM Cause.
Right, and for those cases, we'll identify what's the retention set on the vault, and we'll set as a retention in the plus product. So there's understanding and awareness of the, not just the worm-enabled vault, but also how long the retention is set for.
And then finally, I think probably close here.
Right.
Someone asked about the catalog resiliency. We have a catalog backup function. Basically, you create a separate SLA for the catalog backup. Usually, you want to get that data out in our New York, San Francisco chart. We want to get the data to San Francisco. So you can ingest it directly into San Francisco. You can ingest it in New York and replicate it to San Francisco. You're going to do that as frequently as your most frequent backup. So if you're backing up twice a day, some VMs, you're going to want to do a catalog backup twice a day. And as I said, if there's an outage at one of your sites, then it's a matter of simply deploying the OVA, which is the Spectrum Protect Plus server, reconnecting the Spectrum Protect server with the VSnap repository that's local at that site, in the San Francisco site in that example. And that's just a matter of providing the credentials back to the VSnap server. Once the new Plus server recognizes VSnap storage, it can find all the catalog backups. It knows where to go look for catalog backups that might be there, and you can recover the catalog. And now you have all those recovery points that you had replicated into that San Francisco site are available for recovery in San Francisco.
So should by some horrible chance I corrupt my catalog, lose the catalog, forget to back it up,
Sorry, Mark.
is the data in any way
Change job.
describing in order to be able to go through what's on those VSnap servers?
Not guaranteed to be self-describing.
Okay.
Right.
So I'm screwed then. If I lose the catalog.
Well, but since the data is stored as snapshot in a native format, the data is still available for recovery. We can manually map it and do the data restore.
rebuild the catalog.
But it's not, it's
we
not
can't
rebuilding
rebuild.
the catalog.
There's no rebuild catalog
Right,
sort of
not
scenario.
current.
Not currently, that's correct.
Yeah, but the data is still available for restore. You're not completely dead in the water.
Unless you've managed to mess that up as well.
Yeah, you've
Seen it happen. Seen people do things like that.
Yeah.